got going fast, this was bigger than this. Got it going fast. Why? Okay. Let's go through some of our various forces. We've already talked about the weight. We've already talked about the normal force. We've talked about, now we just kind of introduced air resistance or drag, if you like. We talked about the tension force before. And there's one more really important force that we have to learn about today. And that is, this marker stinks. That's not the name of the force. It would be a cool name for a force though. This marker stinks force. Friction. Today we shall introduce the friction force. Friction is another manifestation of the electromagnetic force. Anytime two objects get close together, you have electrons resisting each other's passage through there. And so if I do this, it's hard to do because the surface itself is resisting my motion.
And really dirty.
What?
And really dirty. Clearly.
Thanks, Maggie. Thanks for pointing that out.
I'm sorry, you really need to clean that.
The friction force. It opposes motion. Oh, that's a nice marker there. Friction always is in the direction opposite the motion. Wherever, not necessarily the acceleration, but the motion. Whichever way it's moving, friction is going to fight that. Friction tends to slow things down, always. Acceleration can slow things down or speed things up, but the friction force always opposes motion. And the friction force, if you want to calculate the friction force, which by the way, F sub F is, what's an F? If you want to calculate the friction force, there's a way to do that. The formula is F sub F equals mu times F sub n. Now, one of those two things you should understand what it is, and the other you probably don't. Which one do you understand what it is? This one, yeah. Which makes sense because, think about it this way. If I have a brick here and a cinder block there, and I try to drag them each, which one should be harder to, which one's going to have more friction? A brick or a cinder block?
A cinder block.
Correct. Now is that, I mean, you just kind of know that intuitively. If you hooked a scale to a cinder block and tried to measure the force you had to pull it with, it would be bigger than the brick.
Oh, okay.
Why? Well, wouldn't the normal force on a cinder block be bigger than the normal force on a brick? And so we expect more normal, in other words, heavier objects are going to have more normal force on them. They would have more weight on a scale. Those are going to have more friction. Now, what is that mu thing? Well, mu is the coefficient of friction. Coefficient of friction. And what it is it's a constant. It's a number. It's something you'll get off of a chart. Coefficient of friction is a constant. Every surface would have a coefficient of friction. So if the problem says you're working on concrete, you'd need to go to the data table and find out what the coefficient of friction for concrete was. I believe that list of some tables, some coefficients of friction is on page 131 for a few common examples. Now, the other thing about that is, you'll notice if you go there that there are actually two numbers for each surface. There's like mu k and mu sub f. The k stands for kinetic, and the S stands for static. Any idea what those words mean?
Moving and stationary.
Moving and stationary. So it actually, a surface will have a different amount of friction pulling it when it's moving than when it's sitting still. So if something is moving, you would use the mu k. If something is not moving, you would use the mu sub s. Now let's talk about units on this. You can go back to the formula and figure out the unit. The unit on friction is, on the force of friction is newtons. The unit on the normal force is. So in order for these to be equal, what does the unit on mu have to be? Okay, so what's a newton times a newton? She said newton. Newton times a newton is a newton? Wait, that's not true. It's a newton squared.
Doesn't have a unit.
Oh, bravo, bravo. Can't have a unit because the units they're already equal, so this can't have a unit. Think of it another way. If you want to find mu, what do? You take this divided by that, don't you? And so you'd have a newton divided by a newton. What is that unit? No unit. Mu has no unit. If you go to page 131 and look at those numbers, they are just numbers. There's no unit on them. So it's a unitless number. It's a unitless constant. I'm going to go ahead and have you stop the video because that's